So my name is Nikola Serafimovski. I come from pureLiFi. We're a young company that started off in 2012 from the University of Edinburgh, primarily focused on initially using visible light communications, but now we've grown to provide light communications in general, regardless of what the band is. Okay? So we've talked a lot about what the technology capabilities are of Li-Fi and why this is very interesting to us. Speed and bandwidth, there was a lot of that went through, especially in the last few slides. Quality of the connection. So again, you will hear, well, I can do the exact same thing that I can with Li-Fi, with WiGig. Why do I care? It's about quality. It's about the impact that you deliver, and it's about that reliability and robustness. Low latency we've talked about, and the security. There's a lot of work around the security of Li-Fi, both physical and from a crypto perspective, and I'll let the security researchers go into that, but that's a giant open bubble for those of you that are more inclined to that space. Yep. So from pureLiFi, there's been a lot of things that you would have read in the space. In short, the messages were already kind of given by the earlier speaker. There's a constant demand, so it's an exponential, right? It's something like 70% year on year. So everybody here should basically know exponential growth, right? Consequences of exponential growth is that you just quite literally one day say, hey, good morning. We can't really do that anymore. Last year was good, this year not so much. And that's just this bump. And if you look back, and I think Stefan did a great job at presenting this, if you look back at the history, so from like the 1960s until about 2000, 2010, we've gone to about 1.6 million times improvement in the megabits per meter squared, right? In the aerial capacity. 1.6 million times. If you break that down, it's like 5x comes from physical layer research, 25x comes from a bit more spectrum, some new MIMO technologies, all of that stuff has another 10, 15, but all the rest of it, around 1.6 thousand times, that's all small cells. So that's a hint, right? The direction of travel that we want to go to is small cells, and this is the ultimate small cell capability. So what can you use this for and how can you use it? Again, going back to the why. So smart home, nobody really here has a problem with their Wi-Fi at home today. I'm just going to hazard a guess. Some of you might, some of you don't really care. But that's mostly because all of us are Europe-based by the looks of things, largely, yeah? So actually, we've been speaking with a lot of telcos and tier ones, especially in Southeast Asia, and there they do have a problem because there's a giant marketing push, justified or not, but there is a giant marketing push to deliver gigabit per second capabilities to the home. The number one complaint the telcos are getting, hey, I paid for a gigabit and I'm not seeing a gigabit on speed test. That's all they care about, right? That's the reality of it. So people demand what they paid for. And when you're advertising a gigabit, how are you going to deliver a gigabit over Wi-Fi, guys? Yeah, of course you can do cutting edge capabilities with 2x2 MIMOs and 160 megahertz of bandwidth coming now with Wi-Fi 6 and all of these things. But at the end of the day, you're doing it in this flat, it bleeds to the next flat, and you're back to square one. By the way, doing it in this flat means doing it in this room because the walls are different from each country. If you're in Edinburgh and you live in a tenement flat, you have half a meter thick bricks, you know, from the 1800s, like solid blocks of stone. If you live in the US, you have paper thin walls that are made out of wood. So Wi-Fi bleeds nice and easy. But that's the challenge. With light, it's all the same. A room is a room is a room is a room. Propagation is propagation is propagation is propagation. It's uniform. So you get a really good understanding for it, which means designing a smart home now becomes a cookie cutter exercise. Once I design a room for Europe, copy paste in Asia, copy paste in the US, copy paste wherever I want. High super density environments, okay, they're the same everywhere, regardless of what the propagation model is. So we see a lot of that utility coming in, especially as there's a transition towards more interactive capabilities. So you'll heard of VR being the buzzword, right? Everybody wants to do VR. VR's got a long way to go, right? For all sorts of reasons, nothing to do with communications technology, mostly to do with system architecture. But bottom line is you still need that connectivity and you still need that low latency and you still need that reliability. And the way to deliver those is by just having smaller cells. And LiFi gives you that opportunity, yeah? Without interference, number one. You can offload to Wi-Fi and connect more users. This is exactly this concept. So who here has a smart connected TV? Show of hands. Very few people. Who here has one device in their home? One device, one mobile phone or one laptop. Who here has one?
At least one.
At least one, exactly. Who's got more than one? Right? More than 3? More than 4? You see how it goes. That's the point. When you're trying to connect all of these things, you're going to have stationary elements and you're going to have non-stationary elements. You're going to have this cross interference. For those of you, some are too young, some have them, some don't. When you have kids, that just blows up. The need for continuous connectivity just blows up, and you lose all kind of ability to use it. So a lot of the people that we work with, actually, they have kids, and the kids want to do gamings, and the pops, the old people like me, we have TVs, and we want to watch the TV, and you can't, because they're both hanging on the same Wi-Fi thing, and if I'm watching TV, that messes up the latency for the gaming bit, and people get slaughtered. That's what's happening. So why should everybody be hanging off of the same wireless medium? Use the wireless medium for what it's useful for. The TV is there, it's stationary, so just offload to it. It's never going to be one technology that solves everything, and for us at least, at pureLiFi, that's a core tenet. LiFi is not a silver bullet. It doesn't solve every single application, and it's not applicable to everything in the space. And if you think it is, you're making a mistake, and it's all about creating that balance. Use RF where RF makes sense, use light where light makes sense. So for us, the ability to create this effective load balancing in exactly the same way. By the way, for those of you that have heterogeneous networks and balanced systems from your providers, I don't know if you're on Deutsche Telekom or if you're in the UK, you're on like Vodafone or Virgin Media or O2, they balance you. So if you have like a home broadband subscription, they'll hook you up to Wi-Fi at home. You'll go off and you'll walk and they'll hand you over to their 4G infrastructure. You'll sit down in a cafe and there's going to be like a public Wi-Fi hotspot and they'll send you back to that. And they'll do this load balancing all the time. Because the number one metric that they care about is dollars per bit, right? How much does it cost them to send the data you want over that wireless medium? Licensed spectrum is very expensive. It is the most expensive thing you can possibly do. So you want to put as many users onto an unlicensed band as possible. And Wi-Fi gives you a lot of that unlicensed band. And that's what it comes down to. Hanging people off of the technology that's possible for them. Band hopping and for efficiency and reliability. So again, if you look at the people that are walking around, if my phone is in my pocket and I'm talking on my Bluetooth headset, light is not your solution here, guys. You really want to stick with RF, right? And just keep that conversation going. But you see all of these monitors? There's a giant move to effectively have completely wireless systems, right? So you show up with your phone, you put your phone down, it somehow magically brings up a screen, connects to the screen, you type on a physical or virtual keyboard, you pick up your phone, and the screen goes dead, and the next person comes around and can do the same thing. That's a lot of bandwidth exchange, right? No cables, nothing like that. You just want to be, literally, I put my phone down, I just want a bigger screen to make it easier to edit text documents. That's all I want, right? That type of approach is not viable when everybody needs to be hanging 4K, Ultra HD displays in very, very close proximity to each other. So you need that type of efficiency and that type of reliability. So just make sure that you're using the technology where it makes sense. Security, we spoke a lot about this. This is very, very important, right? So usually you see this picture in the context of interference, right? Two nodes that are interfering with each other, man in the middle sorts of thing. But actually, if you're going to have these types of systems where all of your data is connected, if you want to avoid encryption, you need to use something that's reliable. You need to know that the data that I'm transmitting to this light isn't being detected on the other side. Enter banking or other enterprise connectivity, yeah? Wireless gaming we spoke about. Device-to-device communication. So a lot of you would have seen some of these things come through from a Wi-Fi perspective. So Wi-Fi 6 and Wi-Fi Direct and all of these things. There's a big push towards that. And again, it just comes down to a user experience. So with Li-Fi, for those of you that have been around in the era of IRDA tried to do this, right? Didn't really work very well for a host of reasons, but we think we can do it pretty well now. And if you can do it, it makes it a very, very appealing, because all of a sudden you can have cooperative gaming, you can have joint video streaming. If you're in a stadium with 50,000 people, in an airplane, on a boat, in a room, if I film my son kicking a goal, I can share that instantly with my wife. I don't need it to go up to WhatsApp, hang on the cloud, and then come down, incurring a whole bunch of costs for everybody in the middle, just so she has the 60-second clip in a super compressed format sitting next to me. So the device-to-device piece is going to play a big, big role as things move forward. Same concept, but just device-to-device on a bigger screen. By the way, there's a huge push for mobile gaming now, a big, big push. And some will argue, well, the next generation of people doesn't really care about big screens. Maybe, until they do. Usually that's how you evolve, right? You watch movies on a laptop for a long time, and then eventually you're like, okay, maybe I buy a TV this year. So what do you get with pureLiFi? We've gone through a number of things, and we've really tried to commercialize this concept and this technology. We've gone through an integrated, so the world's first integrated downlight. That's powered of a PoE+, so you quite literally take a network cable, you stick it in the light, and out comes the Li-Fi access point underneath. We did a Li-Fi enabled laptop. They're custom built uses, phone case, again for a Samsung S5 with a Li-Fi node on it, a Li-Fi pendant where we've replaced it. The point is the technology is super versatile. And you can put it into whatever form factor you want. But you have to be aware of the trade-off. You want to make something 5 nines, 10 gigabits per second, ultra reliable, blah, blah, blah. You need to have the horsepower in the device to make it run. You need to have the bandwidth to get to it, to make it useful. You need to have the bottom device that's going to absorb it and make sure it connects it. Think of the system approach and make sure that you're working within a reasonable framework. Not just, oh, I assume I have fiber everywhere and therefore I can do whatever I want. Think of the practical deployment scenarios. And that's what we've tried to do, right? We know where the cutting edge research is, but between cutting edge research and commercially available, acceptable, revenue generating products, there's that kind of engineering gap that we need to fill. We really do think moving forward though, our focus is very much on that optoelectronic components. That's where we're focusing a lot as an organization, and we've launched some of those capabilities out there already. And we are designing these things to be suitable for mobile device integration. In our view, it doesn't really matter what you do on the infrastructure if you don't have anything to absorb it on the device side. Today, every phone has a camera in it. And if you've seen, the camera has gone from this kind of, oh, it's really cool, it has a camera, to being the #1 sale feature for mobile phones, right? Just the Samsung S20, 100 megapixel cameras, 4 devices. So there's a huge emphasis being pushed on that one feature set, effectively changing what a smartphone means. To get into that space requires a lot of effort and a lot of engineering, but it just shows the viability and the flexibility of OEMs to enable new technologies and bring that if the customer is really demanded.
Quick question, maybe you just answered the question, but I'm wondering how happy are the likes of Apple, let's say, for example, to accept new radio interface on their handsets. Cramped space, low energy. They're not even happy to deploy 5G, let alone a completely new air interface. And I'm not even talking about the fact that, let's say, Apples have to be all sleek and beautiful and no extra hang-ups from it. So do you have any interaction with, let's say, the big guys, and do you have any feedback on how much effort it will take to persuade them to add yet another interface?
Yes, and I'll answer that question in the next presentation. Excellent. Because that is exactly one of the core topics that differentiates what the strategies around that go. So it's the next presentation. Okay, cool. So just to finish off quickly, we have these components that are designed for mobile device integration, and we'll go into why that design looks the way it does. So that's it. That's us. Thank you very much. If you have any questions about me or the technology, let me know.